So let's talk about one more relationship in the Sun, Earth, Moon system. And before we really get into that, we need to understand some of the mechanics of planetary motion and observation. So I'll start out with a vocabulary word, and this is it's kind of an interesting concept, and I'm sure you'll understand it, even though this word is it's a little strange looking. But the word is syzygy, and it is a roughly straight line configuration of three or more celestial bodies in a gravitational system. So the gravitational system we're talking about being our solar system. So that's the sun, earth, moon, all the other planets, everything that, including our asteroid belt and comets and all the other things, that is our gravitational system that we're talking about. So anytime you have three or more celestial bodies roughly in a straight line, that is syzygy. So here in this picture, you've got some things kind of lined up, and this would be syzygy. So let's talk about some different types of alignments or configurations within syzygy. So the first type is called occultation. Occultation. So let's check out this GIF here. In occultation, you have a smaller object being occluded or being obscured by a larger object. So here we have some moons of Jupiter that we're viewing, and then they are occluded. That you are witnessing occultation by the planet Jupiter itself. So you watch them pass through sight until they are blocked by Jupiter. The second type of syzygy is transit. Transit occurs when a smaller object passes in front of a larger object. So here we have the transit of Io coming across the planet Jupiter. So you see that moon just coming right across, and you see the shadow passing there. That is transit. Now, if you're interested in your Greek word parts, whenever we see the word trans, the prefix trans, it has to do with the idea of across. So across the surface, so something small moving across the surface of something larger to the observer. So that is transit. And then the third type of syzygy is an eclipse. And so this is another one of our vocabulary words. An eclipse is the movement of one solar system object into the shadow of another object. So when it comes to syzygy, it's something obscuring the view of roughly the same size, close to the same size, but it has to do with something passing into the shadow of it. So not just something blocking the view, not just something crossing the path of, it's something moving into the shadow of another object. So we're familiar with the first type mostly, and this is the solar eclipse. So this happens only during the new moon. So remember, the new moon takes place when the moon is between the sun and the earth. So the night side here would not see the moon, or not, at least not be able to see any light on the moon's surface. So now when the moon's orbit passes between the sun and the earth, it creates a shadow. So we have different types of shadow here. You have what's called the partial shadow, and this is the penumbra. So right here, this is the partial shadow that comes onto Earth's surface. And then you have the umbra, which is the full shadow. So in order for you to get a view of a full eclipse, which we'll talk about the different types of eclipse here in a second, you would have to be in the full shadow, in the umbra here. So the solar eclipses are a little more rare, and it has to do with the fact that, which we talked about yesterday, the moon's orbit being an ellipse, and also it is a little over 5 degrees tilted away from the orbital plane of the Earth and the Sun. So imagine, see this line here, so imagine that's the orbital plane. It's not going to be like this, that wouldn't be 5 degrees, but it's tilted slightly 5 degrees, and so you're not going to see a full solar eclipse all the time. That is a little more rare, and I'll show you some maps as to how that happens here shortly. So let's talk about the 4 different types of solar eclipse. So the first, as I mentioned, is a total solar eclipse. And this is when the moon completely obscures the sun, allowing the solar corona to be visible. So normally when the sun is out, we don't see the corona. We don't see the outermost part of it because everything else is so bright. So when you have a full total eclipse, you see here this part shining out, that is the corona. The corona becomes visible. Here is the moon blocking the body of the sun, obscuring it, and then the corona becomes visible. So that is a total eclipse. Then there's what is called an annular eclipse. So if you remember, we looked at the orbit of the moon around the Earth, and we talked about how there are times when it is further away, that was called apogee, and then there are times when it is closer to the Earth, and that would be the perigee. So that difference in distance to the moon is actually going to change how the size that it appears to us as the observer. So if the moon is further away, if the moon is in apogee, it's going to appear smaller to us. And so during an annular eclipse, the moon is too far from Earth in order to completely obscure the sun. Now, you're in the total eclipse, you've got it just perfectly obscured so that the corona becomes visible. But in the annular eclipse, you're actually going to have what they call the ring of fire eclipse because it's not completely obscuring it. So you don't see the corona, you see the outer edges of the sun's disk. So that's why they call it the ring of fire. The third type is called a hybrid. And so what's happening during a hybrid is the eclipse is shifting between total eclipse, so meaning completely obscured, you can see the corona, and annular, where it's not completely obscured and you see the outer edges of the sun's disk. And it really depends on your location on the Earth's surface. So let's go back to this graphic here. So you see the difference between the umbra and the penumbra. Your view of the eclipse, your perception, is going to depend on where you are on Earth's surface. So here's a map that kind of shows you the total and annular eclipse paths from the years 2021 to 2040. So you can see it gives some dates and things like that of when the eclipses will be and when they'll be full. And then there's also for the hybrid. So it will depend on where you are, and you'll see whenever there's an eclipse, it'll kind of tell you it's visible from this part of the Earth, this continent, and this hemisphere. So it does completely depend on where you are on Earth's surface. So again, that all has to do with the way that the moon orbits the Earth and how far or how near it is to Earth during that eclipse. Then the fourth kind is called a partial eclipse. This one's a little more common because it's pretty rare for the moon and the sun to line up exactly perfect from our perception. Now, during a partial eclipse, the sun and moon are not exactly in line, and the sun is only partially obscured. So you see, this could be passing from the top down this way, but it just never really covers the entire disk. And it's not the same as an annular either, because this is the full eclipse, but because of its size, it's not completely obscured. Whereas this could be in the right position. This could be maybe in the perigee phase of the orbit, but it still just doesn't line up exactly right. So the next type of eclipse is a lunar eclipse. Here is a GIF that shows you in about 8 seconds what a total lunar eclipse looks like. So during a lunar eclipse, what's happening is the Earth is actually casting the shadow onto the moon. So as opposed to the moon casting the shadow onto the Earth during the solar eclipse. So here's what's happening. So you have the penumbra and the umbra just the same as you did during the solar eclipse, because that is how the sun will cast the shadow on any type of object. So now the Earth is casting the shadow, and the moon actually crosses through the penumbra and the umbra, depending on the position in the orbit of the moon around the Earth. So this, we know, can only occur during the full moon phase of the moon cycle. So just like it had to be over here for the solar eclipse, that's only during a new moon. This only happens during a full moon. Now, this is a top-down profile view. So imagine this from a profile view looking on, and you see the shadow as a circle. It would have to pass exactly through this cone of the umbra in order for it to be a full lunar eclipse. Then what happens during a lunar eclipse is we get kind of this reddish hue sometimes, and they call this a blood moon. And I believe somebody during class the other day talked about the moon kind of changing colors, which is true. So depending on the position of the moon, depending on its orbit, you will get different hues. But you might wonder what is actually happening, because we've seen the pictures of the moon from space, and we know that it's gray and it has a little bit of a darker area here. So what in the world? Why does it look yellow sometimes, or why is it looking red here? And this has to do with the atmosphere of the Earth and the reflection of the sun's light. So our atmosphere scatters blue light, which is why whenever you look up at the sky, you see a blue color, because that is the shortest wavelength and that's what's refracted. So when we look out at the sky during the day, we're seeing the sun's light refracted, scattered into blue light. So during a lunar eclipse, red light is actually passing through Earth's atmosphere, and then that light falls onto the moon, and it gives it this red hue, this red tint that we see during what they call a blood moon. So there's a lot of different things that go into creating an eclipse, and we see that there's a lot of things that have to line up exactly right for there to be a total solar eclipse or a total lunar eclipse. And the mechanics and the physics of it, they have to be right on. Otherwise, you're getting a partial or you're getting an annular. So these really are, yes, they are natural phenomenon, but they really take a lot of different factors into account when it crosses right like that. So it is still something that's pretty amazing. But this is the last relationship in the Earth-Moon system that we're going to look at.